Today class we discussed some problems based on the left limit and right limit. Okay. Uh, First exercise: if if your function is defined by your f of x defined by x e power 1 over x over 1 plus e power 1 over x, so that limit of x tends to 0 f of x exit, so that right limit of f of x s length to 0 exit. Uh, for this question, first of all, you want to understand, suppose this limit exit means, suppose this limit exit, therefore, suppose this limit is f of x s length to a equal to L. We have some theory parts, theorems. The left limit to f of x, left limit x length to a minus, it is your left limit, and also it is your right limit x tends to a plus. Suppose this limit exit if and only if this left limit value is equal right limit value, that value is equal to this L. Okay, value is equal to that L. Therefore, we use this fact today class for some questions. Okay, right. Therefore, now we want to calculate this left limit and right limit. Both are equal. You can say that that limit is exit. Right? Suppose both are not equal, then you can say that the limit is does not exit. Okay, right. Here your point is x length to 0. Okay, then you can find some points here: 0 plus h, 0 minus h. Okay, h is positive. Okay, now, okay, first we will find the left limit. It is a right limit, it is a left limit. F of x s length to 0 minus. Minus denoted by 0 minus means it's a left limit. Now we can change the variables. Here x there. Now we have s tends to 0 minus. Therefore x minus 0 you put h. Therefore x minus 0 to put h. Okay, now we can change the variables. Suppose you put here h, then the 0 means here f of h is, sorry, your x is here. Obviously this, we can write obviously this minus h less than 0. Okay, minus h less than 0. Okay, this limit, therefore, you put x equal to, right, you put x equal to minus h less than 0. Suppose s equal minus h means, what is the f of x? F of minus h. Because here we take the limit s less than 0 case. See, s length to 0 minus means you can, right, you can take the values from 0 minus h to 0, not equal 0, but 0 minus h to 0. Therefore, you can find any points here, right? This is one of the points, 0 minus h. Therefore, f of x equal to f of minus h. F of minus h. Understand? X is one of the point because x does not take the value 0, s less than 0. S less than 0, one of the point minus h. This point less than 0 case there. Greater than 0 case, point h there. For a less than 0 case, minus h there. Right? Minus h there. At that point, minus h less than 0. Therefore, what is to f of x equal to f of minus h? F of minus h means you can apply this part. You put x equal to minus h. Then you have minus h. You put limit h length to 0 minus h e power minus 1 over h. Is it okay? 1 plus e power minus 1 over h. Okay, right. Suppose here h is less than 0, right? Here you put 0, 1 over 0, infinity, e power minus infinity, 1 over infinity, 0. Therefore, this one 0, h also 0, 0 over, here this one 0, 1, 0 over 1, your limit value is 1. Okay, sorry, 0 over 1, your limit value is 0. This is for the h less than 0 case. Okay, h less than 0 case, understand? Right, did you understand this part? Right, h less than 0, right? Okay, now this is your left limit. Now we want to find the right limit, limit of f of x, x length to 0 plus. 0 plus means you can put any values. For x 0 plus means you can put here some values. We put here 0 plus h. Therefore, you put f of h length to 0. Now, you can apply that function f of x equal this one, you put x equal to h. Then h e power 1 over h, 1 plus e power 1 over h. Suppose h length to 0, what is the value for this part? You can divide it by, multiply, sorry, you can multiply by e power minus h and divide by e power minus h, we get limit of h over e power minus h, understand, minus 1 over h plus 1. H lends to 0. For this limit value is this one, 1 over infinity become, 1 over 0 become infinity, e power minus infinity, 1 over e power infinity, 0 plus 1, 1, h is 0, therefore 0 over 1 become 0. Now your left limit value is equal to 0, right limit value is equal to 0, therefore this function limit exit, that limit value is equal to which value? 0. Okay, therefore limit of f of x, x length to 0 exceeds and equal to 0, right? That value is equal to 0, right? That value is equal to 0, right? Now another question, same kind of question, exercise 2, right? If f of x equal x, sorry, yes, wait. This question, okay. If f of x equal e power 1 over x minus 1, e power 1 over x plus 1, so that a limit of f of x s lends to 0 does not exit. Okay, here also same idea. Here 0, 0 plus h, 0 minus h is positive. Okay, here also you want to show that here limit does not exit. The limit does not exit means this is not equal, this condition is not equal. Suppose its limit is one of the value, this is another value, they are not equal. You want to show that this is not equal, then you can say that the limit is does not exit. Okay, now we will try limit of x length to 0 minus left limit f of x. Limit of x length to 0 minus means you can take values here. Now you put minus h. Therefore, f of minus h. F of minus h means h length to 0 at that point, right? Because here x equal to minus h, obviously less than 0, right? Obviously less than 0. Suppose x length to 0 means h also length to 0. H length to 0 means h also length to 0. Okay, right. Now You can put this values in this equation. Limit of h lends to 0 e power minus 1 over h minus 1 e power 1 over h plus 1. Sorry, here h is minus, they have a minus. Okay, now what is the limit value? Suppose you put here 0, 1 over 0 infinity, e power minus infinity, 1 over e power infinity 0, therefore minus 1 over 1, therefore minus 1. Okay, minus 1. Okay, this limit is minus 1. Right? It is your left limit. Now we will find the right limit. Limit of x lends to 0 plus f of x, limit of h lends to 0. Here, your right limit here, x value is here, right? X equal h, right? X equal h, because here, for this case, your h is x equal h because h is greater than 0. H lends to 0 means h also lends to 0. For this one, for this case, here, f of h. Now, limit of h tends to 0, you put f of h here, x equal to h, then means e power 1 over h minus 1, e power 1 over h plus 1. Now, suppose here h tends to 0, 1 over 0 infinity. Therefore, now you can multiply by e power minus 1 over h and divided by e power minus 1 over h, you will get h tends to 0, 1 minus e power minus 1 over h, 1 plus e power minus 1 over h. You put here this your h0, it is your 0 value 0, therefore 1 over 1, you get 1. Therefore, for this limit value is minus 1, this limit value is plus 1. I already mentioned here, limit, you want to show that limit does not exceed. Therefore, this left limit equal, the limit, left limit not equal right limit. Therefore, this limit does not exist. Therefore, limit of f of x s length 0 does not exist. Okay, limit f of x s length 0 does not exist because left limit not equal right limit. Therefore, the limit is does not exist. Okay, right. Okay, next question. Right, next question also same kind of question, right? You do more question, you can easily get the idea to do more, to do any question, right? This is 3 exercise. Examine the existence of this limit. Examine the existence of limit x tends to 2 s squared minus 4 over modulus of x minus 2. Okay, modulus of x minus 2. Okay, now you take one of your functions f of x, this one, s squared minus 4 modulus of x minus 2. Now you have this factorization x minus 2, x plus 2. Here modulus they are, right? Suppose you put here positive value for this case if x minus 2 should be positive. Then only you can write this part, right? Now you can simplify this term. You get s plus 2. Here also you can simplify x minus 2 greater than 0 means x greater than 2. S greater than 2 only you get this factor. But suppose this, suppose you again write f of x equal to s square minus 4 over modulus of x minus 2. Suppose you can factorize x minus 2 x plus 2. Suppose your x minus 2 less than 0, your modulus value minus x minus 2. Okay, minus x minus 2. then this factor cancel, then you get minus x plus 2. For this case, s less than 2. S greater than 2, your value is this one. S less than 2, your value is this one. Right. Now you want to find the limit for this part. Okay. That means now your function f of x defined by like this: x plus 2 minus x plus 2 if s greater than 2, if s less than 2. X equal 2 case, if s equal 2 case, what is the value? Okay, s equal 2 case, it is 4, but in this case also minus 4, they were not equal, like wait. Okay, now you want to check the limit. Okay, you want to check the limit, left limit and right limit. Now you want to find the left limit and right limit. Okay. Here you have 2, then you can find here 2 minus h, 2 plus h is positive. Now for a right limit, okay, right limit, you take okay, you take x equal to, your value is, x is, right limit means you want to find this values, no, limit of f of x s lends to 2 minus. 2 minus means you can take any points here. X equal to 2 minus x. H equal to 2 minus h. Obviously less than 2. Is it okay? Right? Okay. Right. Now, what is your f of 2 minus h value? 2 minus h. Now you interchange the, here your x is there. Now interchange the variable x as in terms of h. Therefore, put here, put you x length h, because s length to 2 means x minus 2 equal to h. Therefore, h tend to 0. Okay, h tend to 0, f of x equal to 2 minus h. For x value, you put 2 minus h because x equal to 2 minus h less than 2. Right. Therefore, f of 2 minus h, your equation is this one. For this case, which case? Less than 2 case means here. Less than 2 case means minus x plus 2 minus h tends to 0 minus times, you put x equal to 2 minus h. Therefore, 2 minus h plus 2. Therefore, limit of h tends to 0 minus 4 minus h. H tends to 0 means this value is minus 4. Okay, this value is minus 4. Now, it is your left limit. Now we find the right limit. Limit of h tends to 0. Here, you take values here, x equal to 2 plus h. Suppose s equal to 2 plus h means h is positive, 2 plus h also positive, it's greater than 2. Greater than 2. It is greater than 2, right? Okay, therefore, f of 2 plus h, what is the value? F of 2 plus h. You want to find the f of 2 plus h because h tends to 0. Now you want to find x equal to 2 plus h. Right? F of 2 plus h, limit of h tends to 0. F of 2 plus h means here your x value is greater than 2. Here your x value is greater than 2. X value greater than 2 means x plus 2. Therefore, x is equal to 2 plus h. Therefore, 2 plus h plus 2. h is less than 0 means it is 4. Here your left limit 4, sorry, left limit minus 4, right limit 4, therefore not equal, therefore this limit does not exist, right? This limit does not exist. Therefore, limit of f of x s length to 2 minus not equal limit of f of x s length to 2 plus is limit not equal, therefore limit of f of x s length to 2 does not exist, because suppose this limit not equal, therefore this condition not satisfying, therefore this limit does not exist. Okay, does not exist. Now another question. You do these problems, then you can easily get the idea, right? How can you find the left limit and right limit for a limit function? Okay, right. It is a finite case. Yeah. Okay, next question. Next question, examine the existence of limit. Examine the existence of the limit of f of x at x equal a, where your function is defined by s squared minus a squared over x minus a. Range of x is 0 less than equal x a. Okay. It is defined by like this: 2a x equal a case. S equal or greater than equal a. You want to check the limit of this function x tends to a. Okay. Same idea. Okay. A plus h, a minus h. Therefore, your a minus h less than a. A minus a less than a means, suppose this, you take here one of the point x. X lends to 0 means a minus h lends to, sorry, h, s lends to 0 means you take x equal to a minus h. X equal to a minus h obviously less than a. Therefore, this h lends to 0 because x lends to a. Therefore, a minus a. Therefore, a minus a becomes 0. Therefore, lends to 0. H. It is for the left limit case, right? Therefore, limit of f of x s lends to a minus limit of f of x, you put here s lends to a minus means you, this interval, no, this a minus delta a, you have already studied, right? A minus delta a and this interval. Therefore, a minus h, delta is your h. Therefore, a minus h one of the point. Therefore, you put x is in terms of h. Therefore, x equal to a minus h f of a minus h. Here h lends to 0. Suppose s lends to a mean h lends to 0. Limit of in your equation f of a minus h here, right? A minus h squared minus a squared over x equal to a minus h minus a. H lends to 0. Here a squared 2ah h squared minus a squared a, you can cancel a terms minus h. Now you cancel a squared terms, limit of h lends to 0, right? H lends to 0. Now you can cancel, if you cancel the minus h term, then you get 2a minus h, right? 2a minus h, right? Suppose you h lends to 0 means it is your 2a, right? H lends to 0 means it is 2a. It is a is this limit left limit for right limit, limit of f of x s lends to a plus limit of f of, you put a equal to x equal to a plus h, that case h tends to 0. That means here like this, is you a plus h obviously greater than a, your x is, so x is length to a, x is length to a, therefore suppose x is length to a, your h is length to 0 because you take x equal to a plus h. Suppose s is length to a, take the limit both side, x is length to a means a, therefore a is cancelled, you get h length to 0. Okay, therefore h length to 0, f of a plus h, limit of, right, f of a plus h means you put here a plus h squared minus a squared h equal to a plus h a. You cancel term a, right? H tend to 0, right? H tend to 0, limit h tends to 0, a squared 2ah plus a squared minus a squared a squared 2ah a squared minus a squared over h. Your a squared cancel, h also cancel. Suppose h length is 0, you get 2a. In this case also 2a. Okay. Therefore, right, therefore this is limit, this left limit equal to a and right limit equal to a, and also limit of x length to a, that case also 2a. Therefore this limit is exit. Okay, this limit is exit. And therefore limit of f of x s length to a minus equal limit of f of x s length to a plus, is both limits are equal and this limit equal to 2a, right? 2a equal to limit of f of x s length to a. Therefore under this part, suppose this limit equal this limit and this limit value is l, no, that's l equal to this limit also. Therefore limit does not, sorry, limit exit, that is limit of f of x s length to a exits. Okay, exits. Next question. Next question. Exercise 4. Examine the existence of the limit f of x at x equal 1. Here your f of x equal s squared 2 when s not equal to 1, when x equal 1. Now you want to check the limit, whether this limit exists or not. You want to check. Okay. So you want to take the limit. Check the limit for x tends to 1. No. Therefore, for this part, you take 1 here, 1 plus h, 1 minus h, plus h, 1 minus h. Suppose you take h greater than 0, you take first, suppose h greater than 0, you take first x equal to 1 minus h, here h greater than 0. X equal 1 minus h means, suppose h tends to 1 means, take the limit for here 1, 1 minus h, therefore h tends to 0. H tends to 0, and you can find the f of 1 minus h values, because 1 minus h less than 1. 1 minus h less than 1 means your function take the value here, x does not equal 1. That means x greater than 0 over there, x less than 0. You can expand this one again like this. F of x s squared, again s squared 2, if whether x greater than 1, whether x less than 1, if x equal 1. Okay, not equal means greater than 1 or less than 1. Okay, greater than 1 or less than 1. Right. Now you want to find the left limit and right limit for this equation. So this function. Let obviously this h positive, therefore you take x equal to 1 minus h. This one also 1 minus h, right? This one obviously less than 1. Therefore, your function f of x equal to f of 1 minus h. F of 1 minus h means s squared, 1 minus h squared. Therefore, 1 minus 2h plus h squared. When it is 1, yeah. And suppose you take x equal 1 plus h. In this case, greater than 1 values. Your function take the value, again, you put x equal to 1 plus h. Here also, greater than 1 also, your function take the value f plus h squared, f plus h squared, s squared. That means 1 plus 2h plus h squared. Now you want to find the left limit and right limit. Left limit means limit of f of x, s tends to 1 minus. Okay, s tends to 1 minus. Therefore, it is your limit of f of x equal to 1 minus h. Here, your h is, I already discussed, suppose x equal 1 minus h means h tends to 0. Right, h tends to 0. Therefore, limit of h tends to 0. What is f of 1 minus h? F of 1 minus h equal to this one, 1 minus 2h plus h squared. You put the values for h is 0, then you get 1. And also suppose here x equal 1 plus h greater than 1. Therefore, your x is length to 1, therefore your h also length to 0 on that case. Right. That one's for the right limit. F of x s length to 1 plus limit of h length to 0 1 plus h length to 0. F of 1 plus h means f of 1 plus h is 1. 1 plus 2h plus h squared. You put the values for h is 0, then you get 1. Therefore, here 1, or left limit equal right limit, and also right the limit values here, right. Yeah, left limit equal right limit, and also your limit values is this question. Therefore, the limit of f of x s length to 1 minus equal limit of f of x s length to 1 plus. This value is equal to 1. But limit of x tends to a, right, x tends to a, right, limit of x tends to a, on that case you have to take the value 2, no? Therefore, this limit does not exist, because suppose here you find you put here 1. Suppose you have here 1, okay, your limit is exit. Suppose you have here 2, no, you have here 2, right? For this case, limit does not exist. If x equal, sorry, this limit values, suppose if, right, you can addition, you can run by, if x equal to 1, your f of x equal to 1, the limit is exit, then only you get 1. Okay, now here 2, no, you have not equal, the limit does not exit. Okay, limit does not exit. Now we will do this question. if f of x equal is a polynomial, right? A naught x power n, a1 x power n minus 1, a2 x power n minus 2, and so on a n. It is a coefficients a naught, a1. You know, polynomial like this, f of x equal to s squared plus 2x plus 1. It is a polynomial. Yeah, its coefficients a naught, a naught here 1, a2 is 2, a3 is 1, like that. Okay, this is power here, x and there. It is polynomial for this part x plus 1 and like that part. This is the polynomial x plus a in like that. Okay, right. It is a polynomial a n. Then prove that limit of f of x s length to c f c. This is your question. Now we move to the right. We move to the this for this polynomial. You want to find the limit, right? You want to find the limit for this polynomial. Okay, right. For this part, for this part, your first claim is first. This is your solution, right? First, we shall show that. First, we shall show that this limit is c, limit of x length to c, right? X, suppose you put x equal to c, then you get c. Okay. Take, first you put this limit condition. Okay, you already studied that. How can you put the limit part? First, take any given epsilon greater than 0. Let your e of x equal x. You take this as e of x. Then, what about the modulus of e of x minus c? It is your x minus c. Okay, whenever, right? Otherwise, for all x satisfying 0 less than x minus a less than delta. So it's s minus c. Okay, now choose. Now you want to prove that this x minus c less than epsilon. That is your claim. Therefore, choose delta equal epsilon. That's all. Positive. Delta equal epsilon. Then your g of x minus c equal to x minus c less than delta equal epsilon. That is, the Rx is delta greater than 0 such that Ex minus c, right, Ex minus c less than epsilon for all x satisfying, right, 0 less than x minus a less than delta, right. Therefore, that is limit of, since epsilon greater than 0 is arbitrary, since epsilon greater than 0 be arbitrary, therefore this result is true for all x values. Therefore, for all epsilon greater than 0, the Rx is delta greater than 0 such that Gx equal to x minus c less than epsilon for all x satisfying, right, x satisfying 0 less than x minus a less than delta. That is, right, x minus a less than delta. Therefore, this limit takes it, that is limit of x lends to c, x equal c. Okay, the limit is exit. right? Now we already know this result. We know that because we want to using this result, therefore we want to recall now. We know that if this limit of pi of x, suppose s tends to c, you get pi of c. You put this value is L. Okay, this value is L. And limit of psi of x, x tends to same A, sorry, x tends to C. X tends to C here also C, it is your M. And K belong to real number. And one of the now K, another number, real number K belong to real number. Then we state something, right? Then these are the theorems, right? Basic theorems of the limit of pi of x and psi of x, x tends to C. You can take the, this limit is equal to L plus M. It is your theory parts, properties of the limit, L plus M. Similarly, for a scalar multiplication of the limit, K pi of x, S tends to C. We recall first. This one you can write limit of pi of x, S tends to C. It is your K L. Okay, it is your K L. Now, product of the two functions, pi of x, psi of x, x tends to C, right? You can take the product of, separately you can take the product, x tends to C into limit of psi of x, x tends to C. It is your LM. Division also there, right? Okay. Now, if n belong to natural number, in this case we use this fact, right, to our problems. Limit of whatever this xn, x tends to C, right, s tends to C value. This one you will write Sn becomes S1 SSS dot x tends to C x and so on s n times. Okay, n times. Then here 2 times function. Now you know that here your function is s, here psi is x, like that. Here n function there x. Therefore you take the limit lm for 2 function 2 limit lm. Therefore here x tends to C x. What is the limit? X tends to C x equal to C. Okay, C. Therefore, what I'm saying here, this is one of the limit. It is another limit. It is another limit. Therefore, common terms C up to n. Therefore, C power n. Okay, C power n. Okay, C power n. Now your question is, right, C power n. Now limit, you take limit f of x s tends to C. Okay, f of x s tends to C. No, therefore your f of x equal to what is the value? Under this one you can write limit of x tends to C. Your f of x equal to that function a naught xn, a1 xn minus 1, a2 xn minus 2, and so on an. Okay, and so on an. Therefore, we take the limit for that part, right? It is the scalars. Therefore, scalars into one function means you can separate the scalar and you can take the limit like that. Here a naught separately, and you can take the limit x tends to C xn. Like x tends to C xn, what is the value? C. Therefore, this is your C, but your scalar they are already a naught into C. Right? It means you can take the limit like this: limit of s tends to C a naught xn. Limit of, because Suppose this is one of the function, another function, you add these two functions, you take the limit for each of the function. This limit function plus this limit L plus M, like that. Limit of S length to C, A1 x n minus 1, and so on. Limit of S length to C, A n. Okay. This limit is A naught, n x length to C, xn becomes C to the power n. C power n. What is the value of this one? A1 C power. Here up to n means Cn. Up to n minus 1 means Cn minus 1. Cn minus 1. And so on. Last term should be An. Because of the term An minus 1, C plus, last term is An. Right. It is your answer. Right. Now, you check this answer. Suppose it is your f of x. No, in the f of x, you put x equal to c. You put x equal to c, and you get this answer. X equal to c, you get this answer. Right. Next question. Next question. Examine this limit. Examine limit of a power x minus 1 over x s length to 0. Right? You put a power x equal to y. Think about this one. You take ln both sides, ln ax, ln y, x, ln a, ln y. Therefore, your y is e power x ln a. Right? E power x ln a. Right? You put ax equal to y, no? Y equal, it is your ax. Right? Because this factor is very important, right? Then we use this for e power x, we use this factor, e power x ln a. Then you can easily simplify, right? Limit of Here also h tends to 0 means you take the limit 0, 0 plus h, 0 minus h. Therefore, minus h, you put first x equal minus h because it is less than 0. Then f of minus h, you can find it. Suppose x equal to, in this case, h tends to 0, therefore h also tends to 0. Therefore, x tends to 0 minus f of x. Limit of f of, you put x, x equal to minus h, no, minus h tends to 0, right? Uh, f of, you put here limit of, right, limit of e power f of minus h means, right, f of minus h means okay, a power x by, then you put e power x, your minus h ln a, right, minus h ln a, okay, minus h ln a minus h over here your x is, right, x is h minus h tends to 0. What is the limit? It is easy. H tends to 0. What is the expansion of this one? 1 minus h ln a, 1 minus h ln a next terms plus a squared 2 factorial ln a only squared and so on. Minus h also there, no? Okay, okay. Minus h, yeah, first term e power x means 1. Okay, e power, sorry, here 1, sorry, minus 1. Therefore, so on this factor minus 1 over minus h. I think so many factors are we can cancel. Minus 1 cancel. Minus h you can cancel. You get h tends to 0 only ln a. Therefore, your value is ln a. Okay, ln a. Similarly, for the right limit, say left limit, no? Maybe the right limit, right limit, limit of f of x h tends to 0 plus limit of f of x 0 plus h tends to 0. Therefore, limit of h tends to 0 f of h. That means here, suppose x equal h case, x equal h case positive greater than 0, therefore h tends to 0, f of h is a left limit, sorry, right limit. Therefore, limit of h tends to 0, this is your e power h ln a minus 1 h. Therefore, limit of h tends to 0. Here all terms are positive, no? 1 plus h ln a a squared over 2 factorial ln a and so on minus 1 over h. You can cancel the term 1 1, you can cancel the term 1 1. Then h is cancelled, you get here ln a, others are 0. Therefore, your left limit equal right limit. Therefore, this limit of right f of x s length to 0 minus limit of f of x s tend to 0 plus is exit equal ln a, therefore is exit, right? Therefore this limit is exit, right? Therefore this limit is exit. Therefore limit of f of x s length to 0 exits. Okay, limit exits. Okay, this limit is exits. Next question. Right, next question. Next question. The limit of 1 over x e power 1 over x s length to 0. You want to check this limit, whether this limit exists or not. Okay. Here, so 0, 0 plus h, 0 minus h. Okay, for this question, you want to find the left limit and right limit. Examine this limit exit or not, right? Your f of x equal to 1 over x e power 1 over x. Therefore, limit of f of x s length to 0 plus means right limit s length to 0 plus you put f of h because yeah h 0 plus h means h greater than 0 at h greater than 0 it is a right limit h greater than 0 what is your f of h values limit of you put here h length to 0 because h length to 0 means you take x equal to h h length to 0 means h also length to 0 limit of h length to 0 right f of h f of h means 1 over h e power 1 over h right 1 over h e power 1 over h therefore this limit values should be 1 over 0 become infinity therefore it is your infinity values no it is your infinity value what about this um, x length to 0 minus that means right limit this one limit of f of you put a here minus h no x equal to minus h then suppose h length to 0 means h also length to 0 0 minus h length also h length to 0 therefore h length to 0 f of h means here 1 over h e power 1 over h length to 0 what is the value of this part uh, sorry minus h therefore this value should be 0 right 0 therefore both are not equal therefore limit does not exist therefore a limit of f of x s length to 0 does not exist okay does not exist next question next exercise here also you want to check whether this limit exit or not right in here this case limit exit you can check that one limit of for this question limit of f of x sorry limit of 1 plus x to the power n minus 1 over x polynomial x length to 0 therefore your f of x is equal to 1 plus x to the power n minus 1 over x right therefore you can take the limit for the f of x s first x length to 0 minus 0 minus therefore your limit is limit of h length to 0 f of minus h no f of minus h because here you put f of minus h therefore because 0 0 plus h 0 minus h therefore minus h less than 0 therefore f of minus h you can find from this equation limit of h length to 0 f of minus n you put x equal to minus h therefore 1 minus h to the power n minus 1 minus h therefore limit of h tends to 0 1 plus n times minus h n n minus 1 over 2 factorial right minus h squared and so on up to n Last term should be h to the power n, yeah, minus 1. Last term should be h to the power n over minus h. Suppose to take the limit is 1, you can cancel 1, 1. Then to take the limit, this minus is minus is cancel. First term only exceed, other terms should be 0 because h term, then the 0, no, because 0, therefore your only one terms equal n. What about your, it is for left limit values. For right limit values, limit of f of x s length to 0 plus. Similarly, limit of f of x s length to 0 plus. Sorry, s length to 0 plus means here put here f of, suppose here h is positive, therefore f of minus, usually take f of minus, sorry, f of plus h. Suppose s length to 0 means h length to 0, f of h plus h. Therefore, this one limit of 1 plus a power n minus 1 here h. H length to 0. You can expand this one 1 plus n h n minus 1 over 2 factorial a squared and so on minus 1 over 2 factorial h. Okay. Now you can cancel the term 1 1, this 1, then only cancel the term h is here. Others are, suppose h length is 0, others are 0. Only your remaining term is n. Right? It is n. Right? This value is n. This value is also n. Therefore, left limit equal right limit. Therefore, this limit exit, that limit exit that the value is equal to n. Therefore, uh, therefore, therefore, limit of 1 plus x n minus 1 x s tend to 0 exits, right, exits equal to, what is the value? N. Okay, what is the value? N. Right. Next question. Next question, you want to show that this limit also exit, right? You want to show that examine the existence of limit s length to 0, s length to 0, so s length to a, s power m, a power m, x minus a. Okay, right. Here also you want to check the left limit and right limit, both are equal, and you consider the limit is exit. suppose both are not equal, then you can say that limit is does not exist. First, we can find the left limit a plus h, a minus h. Therefore, you can take this point first. Suppose yeah, a minus h less than a. Therefore, f of suppose you take x equal to a minus h. Therefore, x equal to a minus h means suppose x length to 0 means s length to s length to s length to a means is a minus h. Therefore, h length to 0. H length to 0. Suppose you take a plus h greater than a case, you take x equal to a plus h. In this case also h tends to 0. Right? For this case, you can find the f of a minus h values. Here also you can find the f of a plus h values. Right? First, for a left limit x tends to a minus f of x. Limit of f x equal to a minus h. H tends to 0. Limit of right if a minus h means a minus h to the power m minus a power m over x equal a minus h minus a. Right here h tends to 0. Therefore, limit of h tends to 0. Suppose you take one of the factor here a m outside, you have 1 minus h over a m. Okay, a m. Okay, a m. Or you get this factor is cancelled, minus a is cancelled, you get minus h. Okay, now you take now is a power m is common for both here, therefore you take outside a power m over minus h there. Okay, a power m over minus h there. For this factor 1 minus right 1 minus m into h over a plus m minus 1 2 factorial h over a squared and so on. Last term h over m to the power m. Here you take am outside, therefore you get minus 1 over it's h here. Okay. Right now, suppose h length is 0. No? From this part, you cancel this term 1 and minus 1. Then your first term you go minus a my h cancel minus plus a power m over m times. That means your answer is m into a m minus 1 because other factors are they have one of the term h product of h term there here. Therefore, other factors are should be 0. Therefore, you get m a m minus 1. Okay. Therefore, your left limit equal this values. Now we check the right limit. Okay. Left limit equal to m a m minus 1. Now you check the right limit. Okay. Limit of f of x s lends to a plus. Right. It is limit of I already mentioned here. It's equal to a plus h for a right limit. H lends to 0. It is an equal to limit of h length to 0 here a plus a power m minus a power m over a plus h minus a. Then you get limit of h power 0. H power m you take outside, you get 1 plus h over a. That means you can move here like this here. A power m you get outside 1 plus h over a, right? M minus a power m over h. Right now, limit of h tends to 0, right? A power m over h 1 minus 1 plus 1 plus h over a m m minus 1 over 2 factorial a squared over a squared, right? H squared over a squared, and so on, right? Okay, and so on, minus 1. Okay, minus 1. Then you see minus 1 is plus 1 is cancelled. Then only your first term, in the you multiply here, the h is cancelled, then you get a power m minus 1 m. Other terms, one of the product with h there, therefore other terms should be 0. Suppose h is 0, no, other terms should be 0. Therefore, you get for this limit values m into a m minus 1. Here also your m into a m minus 1. Here also your value is m into a m minus 1. Therefore, both limit values are equal. Left limit equal right limit. Therefore, this for this function limit exit equal m a m minus 1. That is limit of s to the power m a m x minus a s length to a exit limit exit and equal, right, m a m minus 1, right, m a m minus 1 exists and equal m a m minus 1. It exists and equal m a m minus 1. Another question, equal m a m minus 1 and equal, let's wait, m a m minus 1 and okay, right. Now okay, okay, these are the based on the left limit and right limit parts, right? Okay, you can, right, uh, you understand this, uh, suppose you understand this uh, theory parts, that left limit equal right limit, then you can do like these questions, right? You can do more questions like this. Okay, this is the idea, right, to do that problems based on the left limit and right limit. Okay.